Hi, welcome back to Mystic Chemistry. This is Charles Gassel, lesson number 6. Okay, we can look at the flow chart here and say that 1 atmosphere can equal 760 millimeters of mercury, which equals 760 torr, which equals 101.325 kilopascals, which equals 101,325 pascals, which equals 1.013 bar, which equals 14.7 pounds per square inch. Standard temperature and pressure, of course, is 0 degrees Celsius at 1 atm. 1 millimeter mercury equals 1 torr, K equals C plus 273, 1 milliliter equals 1 cubic centimeter. Charles' law is V1 over T1 equals V2 over T2, but better written as V1 T2 equals V2 T1, and our pressure is our constant. Okay, let's look at our first problem here with Charles. A balloon has a volume of 2,500 milliliters on a day when the temperature is 25 degrees Celsius. If the temperature falls to 17 degrees Celsius during the night, what will the new volume be? Okay, so we have 2,500 for our first volume, milliliters. Our temperature was 25 degrees Celsius, of course, and our new temperature is going to be 17 degrees Celsius, and we're looking for our second volume. First, we need to convert our temperature. So T1 equals 25 plus 273.15. T1 is going to equal 298.15 Kelvin. T2 is going to be 17 plus 273.15, so that's going to T2 is going to equal 290.15 Kelvin. So we want to isolate for V2. V2 equals V1 T2 over T1. V2 equals then our V1, which is 2,500 milliliters, remember, times our second temperature, which would be 290 K, some change, here we go, divided by our initial temperature, which was 298.15 K. K's cancel out, and we simply do the math now. So let's go and do the math here and see what we get. We get, see, 2,500 times 290.15 divided by 298.15, and I get a grand total of, which looks like 2,432.92 milliliters. So I get 2,432.92 milliliters. If I want to convert that to liters, I would just say the volume is 2.43292 liters. By moving the decimal 3 places over. Pretty common sense stuff. All right, so let's look at our second question here. 34 liters of gas is at 500 K. How many liters will it occupy at 4,000 K? So our T2 temperature is 4,000. Our T1 temperature is 500 K. And our volume 1 is 34.0 liters. So we're looking for V2 again. So we're not doing conversions this time, because it's already in Kelvin. So V2 equals V1 T2 over T1. So we plug in our values. Our values are going to be 34 liters, snarls, times our T2, which is 4,000. Okay, that's pretty hot. Divided by our 500K, which is probably pretty musty toasty too. So K's cancel out. V2, that's going to be interesting here. It's going to be 34.0 times 4,000 divided by 500. It's going to give me 272.0 liters. Right. So this is going to give me 272 1.0 liters. Well, that's it for this lesson, guys. You be snarly. I will see you back here at Moosine Chemistry.